Yeah, so I'm very pleased to introduce Arjuna Sivakumar from IBM. Please take it away.
How does this work?
So it should be the service. Forward.
Thank you. Hi guys, I'm Arjuna. I'm an ambassador for IBM Quantum, and I've been at IBM for 2 years now. I joined as a graduate in 2020 during the pandemic, so like Earl, this is really my first public speech. My job is trying to translate what you intelligent guys come up with, the technical side, and translate that into commercial and industry application for our clients. By the end of this talk, I hope to paint a clear picture of IBM Quantum, the ecosystem, and the belief and the knowledge we have as to why we're going to pioneer this revolutionary new era in technology. There's a lot of excitement and hype around quantum computers, and IBM, like everyone else, believes that this is a technology that will fundamentally revolutionize not only technology, but business, science, and society. We want to push the frontiers of our understanding of consciousness. And so to really understand the paradigm of computing that we're about to enter and why the rate of progress that we'll make will really be unprecedented, let me take you back in time to the genesis, what many people perceive to be the birthplace of computational science. As you all know, in 1936, Alan Turing devised an abstract notion for what we'd now call a programmable computer. And some years later, we would develop the world's first digital computer that performed Boolean and counting operations. The Colossus Mark II then followed, developed during World War II, and it was extremely significant because most historians believe that the use of these machines significantly shortened the war by providing evidence of enemy intentions. At the time, it would take weeks, maybe even months, to crack encrypted messages, but Colossus was able to do that in just weeks. With classical computation, the world saw a rate of progress like no time before. But there was one caveat to that rate of progress, and is that we were using a system of computation that didn't fully encompass the nature of our reality. Now let's fast forward to 1981. You're at a conference organized by MIT and IBM, and Richard Feynman stands in front of you and he says, "Nature isn't classical, damn it. If you want to make a simulation of nature, you'd better make it quantum mechanical." And for decades, we've been simplifying nature into ones and zeros because that was the only way we could manage to create a useful and scalable system of computation. But the future wasn't just ones and zeros, and that was what made quantum launch. Let's bring you back to 2022. Let's bring you back to the future. The great thing about 2022 is we have access to the cloud. Unlike the advent of the classical systems in the 40s, where access to this was extremely limited and only a handful of people had the opportunities to learn and understand the digital system, today we leverage the power of IBM Cloud. In 2016, IBM brought to the world the first commercially available quantum computer for everyone on the cloud free of charge. The IBM Quantum experience greatly increases exposure and development in both hardware and software. Quantum, in combination with IBM Cloud, means we'll see a growth in the quantum industry that will be unprecedented. And since its inception, 29 quantum computers have been deployed on the IBM Cloud. And from this, we've gained over 1,400 scientific research papers in collaboration with our 181 members of the IBM Q network. On the right, you see our IBM Q System 1, and it's a bloody beautiful machine. It's considered the crown jewels of IBM's business, so much so that the state-of-the-art casing was designed by the company in Milan who did the casing for the royal crown jewels in the Mona Lisa. And as you know, quantum computers are very fragile, so the casing had to be engineered to maintain thermal stability to protect the sensitive qubits. There are problems that can be solved on a quantum computer quite easily, which are impossible for classical systems, as you all know. And these problems, IBM call quantum possible. They touch industries like chemistry, pharmaceuticals, machine learning, and optimization. Let me get you excited on some potentials. What are we doing with quantum in the future? What work are we doing with our commercial business partners? And what's IBM's plan for the future? We're now emerging out of a devastating pandemic that has destroyed societies, businesses, and most of all, the lives of human beings. But I wish we had a fully functioning quantum computer today, because quantum would play a significant role in advancing drug development. Pharmaceuticals have an abiding interest in enzymes because these enzymes catalyze biochemical interactions. And so harnessing the power of enzymes may alleviate the major diseases of our time. Unfortunately, the exact molecular binding structure of most enzymes is unknown. We can't even simulate the binding structure of the coffee that you're drinking. But with a sufficiently powerful quantum computer, we could accurately predict in a matter of hours the properties, the structure, and the reactivity of such substances. Quantum will drive faster development of new drugs, leading to transformative new cures and potentially even individualized medicine. So what's IBM's plan for the future? In February last year, IBM Quantum announced its development roadmap. It showcases an integrated vision and a timeline for full stack quantum development, including hardware, software, and applications. The key features highlighted on the map here are the QCTIP runtime, announced in 2021, which enable 120x speedup on most of our quantum chemistry algorithms, and the capability to run dynamic circuits in 2022 that will allow greater circuit variety and expands algorithmic complexity in our systems. On the hardware side, we currently have a 127 qubit machine, the Eagle, and we're due for the end of this year, our first 433 Falcon processor. Our quantum scientists are advancing our methods towards building our first 1,000 qubit machine in 2023, the Condor. And with this, we'll be capable of exploring applications with quantum advantage by the end of 2023. We've delivered every year with what we said, and we're making progress as our average error rate continues to go down year on year. And it starts to get even more exciting with the potential of 1 million plus qubits by the end of the decade and the potential heavyweight of problems that we could solve with a machine of this magnitude. And just today, IBM Quantum in New York, they announced that they've released the QCTIP runtime primitives. And this starts our journey to creating a truly user-friendly, frictionless quantum experience. QCTIP runtime primitives, for those that don't know, makes algorithm development easier than ever. So QCTIP runtime is a containerized execution environment for quantum classical programs. And we've now evolved the concept to make it simpler for a programming experience via QCTIP runtime primitives. So developers need more than just hardware and better quantum hardware. With the primitives, we eliminate large performance bottlenecks to workload performances and will deliver an experience that's already faster, more efficient, and better matched to the needs of the algorithm developer. IBM's vision, essentially, is to create a programming environment where the underlying intricacies of the technology are no longer a concern to users. And over time, we're going to introduce more tools, such as error suppression and mitigation, further enhancing its power. Let me tell you a bit about the IBM Quantum Network. So we have 181 members in IBM's Q network, and there's 5 different levels to our membership. We have our partners, hubs, members, startups, and academia. Our hubs are quantum institutions that are advancing education and exposure to the next generation. Our members are organizations that want to understand their quantum strategy for the future. And our partners are exploring real-world applications for quantum that are faster than classical systems. Some of the work we're currently doing, we're working with Daimler, the parent company of Mercedes-Benz, in the hope that quantum computing will help them design next-generation lithium-sulfur batteries to help them create more powerful, energy-efficient vehicles. We've also teamed up with JP Morgan Chase. With added regulation and standards and a consistently changing trading landscape, investment managers have been struggling to incorporate real-life constraints such as market volatility and customer behavior into their portfolio optimizations. Rebalancing investment portfolios that keep up with market movements is significantly constrained by classical limits, and IBM Quantum could help cut through that complexity with its combinatorial optimization capabilities, enabling investment managers to improve portfolio diversification and more precisely respond to market conditions. And only just last week, we announced that HSBC joined the IBM Accelerator Program. The new 3-year collaboration is designed to help HSBC bolster their quantum readiness and ensure the organization is ready to take full advantage of the technology. The bank envisions quantum capabilities for price optimization, sustainability, risk and fraud, and expands internal quantum specialists. Despite all the connections with all the major institutions and partners, IBM believes that the power of quantum lies within the IBM quantum ecosystem. The ecosystem is the most important thing for quantum acceleration. No other entity on the planet possesses the ecosystem of the IBM Q network, and I'll give you an example. IBM Quantum in Zurich developed a paper on amplitude estimation. They then published that paper into the quantum ecosystem, and it was picked up by a university in Japan who advanced the method, republished it. JP Morgan Chase then picked up that paper and applied those methods to their options pricing. They then put that back in to IBM Quantum, and all our members of the network have access to this information and knowledge. IBM Quantum with the ecosystem are pioneering the coming quantum industry. And just before I close, I'd like to say one thing. All of us in this room carry a genuine excitement and an enthusiasm for quantum. This technology has a potential to save lives, elevate the human condition, transform science and society. But something struck a chord with me some while ago, and I remember watching an interview of Robert Oppenheimer, the father of the atomic bomb. And he was speaking in this interview after the Hiroshima disaster. And these were his words. They knew the world would not be the same. A few people laughed, a few people cried, but most people were silent. He then goes on to reference a line from an ancient Indian text where Krishna, who is an embodiment of the divine, is trying to persuade a warrior to fulfill his duty, for his duty is his highest calling. And to persuade him, he shows him his multi-armed form, and he says to him, "Now I am become death, the destroyer of worlds." And as I watched this, as I watched Oppenheimer say these words, I saw the eyes of a man who had lost his soul. He knew the suffering and damnation he had caused on millions of human beings because of his inventions. Let us not become Oppenheimer. Let us not have regrets. We must act consciously and pursue our curiosity with the right intentions. But without conscious effort, a technology created with the potential to elevate mankind could be used as a devastating weapon. With something as powerful as quantum and the early stage that we're in now, we have the power in our hands to ensure that it is only used for the betterment of our people and our planet. Thank you very much.
Are there any questions? Yeah, go ahead.
I just want to follow up on that last point you made about the importance of ethical and responsible innovation. To what extent do you think that process occurs within IBM? Can you give any insight into how that's kind of built into the research that you do?
I think it's more of a conscious effort and a culture that you need to cultivate within organizations and academia. In 2020, Arvind Krishna, our CEO, he realized that we were using face recognition technology, and it was being used in the wrong ways for racial profiling and for various other reasons. And so he decided to take the power in his hands and destroy that technology. We now no longer provide face recognition or any surveillance technology to the White House or any sort of government. And I'm starting to realize that corporations are becoming the new governments, because governments have a slow reaction with the bureaucratic processes. So it's upon us as organizations to initiate this culture of ethics into our product. Yeah.
That's a great example.
Thank you.
Are there any other questions? If not, let's thank Arjuna again. Just get it to 7. So you've got some free time for then, if you want to do some science or have some free drinks.